Okay, we're starting chapter 7 now. This is section 1 on chemical reactions. A chemical reaction is when a new substance is produced because the atoms are rearranged. So some bonds between the molecules are broken and other bonds are formed. For example, if you take, do I have examples? Not yet. Okay, so let me just set your mind here. If you've got something like water, which is H2O, and then you've got something like salt, which is NaCl. So what I'm talking about is breaking apart the bonds that hold the water together and breaking apart the bonds that hold the salt together, and then reforming bonds so that now these two form one molecule and these two form another molecule. Does that make sense? That's what we're talking about here. And what we need to start with, oh, cool picture. What we need to start with is an understanding of the difference between physical and chemical changes. And I think this was chapter 2, but we're going to review it really quick. Sometimes the changes are just physical, and this is not a chemical change. This is just physical changes, like changes in state, going from a solid to a liquid or a gas. That's just a temperature thing. Or if you have salt or sugar and you dissolve it in a liquid, that is a physical change. That's not a chemical change. If you change the pressure, these are different things that you can do to something and change it, but it's still the same substance. If you have a full-blown chemical change, this evidence includes an actual change in color. So I have a yellow liquid here and I have a clear liquid here, and when I pour them together it makes pink. That's a color change. Formation of a precipitate. A precipitate is a solid. So if I pour a yellow liquid into a clear liquid and I get a liquid with little like crystals of solid things on the bottom, sunk to the bottom of the thing, it's formed a solid inside my liquids for no apparent reason. That's forming a precipitate. Then we have formation of a gas, and this looks like bubbles. When you pour a liquid onto a solid, like if you have vinegar and you pour it onto the solid baking soda, you're going to get a whole bunch of bubbles because there's a chemical change happening right now. It is forming a gas. If you have a temperature change and you don't know why, I took the yellow liquid, I mixed it with the clear liquid, I got something frozen. What's up with that? That was a chemical change. Okay? Now, I don't know what that's a picture of. Cool. But we're going to see it twice. All right, cool. Parts of a chemical change. So when you're talking about making a chemical change, the reactants are the substances present at the beginning of the reaction. And these are the ones that are going to react together. So in my water and salt example, I have H2O, I have NaCl. Those are the reactants. That's what I start with. Okay? And then the product, just like a multiplication problem, the product is what you get at the end. So here I've got hydrogen gas and I add oxygen gas, and if there's a chemical reaction I can get water, which is a liquid. And these two, H2 and O2, are the reactants because they're what I started with, and then the product is the water at the end. Okay? Now, there are different kinds of reactions that we get, and they're all based on what's happening. So, the first one is called synthesis. This is when you start with simple products and you form a more complex product. To synthesize something means to take a little tiny pieces of things and put them all together to make something that's more complex. So for example, here, same example, I have two simple things and I make something more complex. So that is synthesis. Okay? Another one is called decomposition, when you start with a complex substance and you break it down into simple substances. For example, breaking down water into hydrogen and oxygen. That's a complex substance broken down into two simple substances. That's called decomposition. Not to be confused with body parts, which is also decomposition. Okay. Oh, look, we took the puzzle pieces apart. That's cool. And then we have combustion. And combustion is one reactant is always oxygen. Another reactant often contains carbon and or hydrogen and so when you put oxygen and carbon and hydrogen together, often your products include carbon dioxide and water and fire. For example, here is CH4 plus oxygen, so you've got the carbon and the hydrogen and the oxygen in your reactants, and you get carbon dioxide and water out of that. But it explodes along the way a little bit. And then you have how fast your reactions go. The rates vary for many reasons, and you can use this list to help you speed something up or slow something down. If you don't want it to all explode, and why you wouldn't want that, I don't know, or maybe you do want it to explode, so you have to speed it up a little bit. So you have to be aware of these three things. The first thing is concentration. The more particles present, the faster the reaction. That's how concentrated your particles are. For example, I use orange juice concentrate as an example. That's where you take a lot of the water out of actual orange juice, and all that's left is this really concentrated bit of orange juice particles, oranges. And that's concentrated. So if you take out, if you want your reaction to go faster, you want to take out all the extra stuff and have a really concentrated sample of whatever it is that you're working on. And if you want to slow it down, then you lessen the concentration. Second way is surface area, because the more particles that are available, the faster the reaction. So if you have this big chunk of something and you're trying to eat it away with acid or something like that, and you pour it on top, yeah, it'll work, but it'll take a while to get down through the layers and the layers and the layers. If you break it up into a bunch of little pieces, now it can get at all of the surface area, and it can eat it away from the inside out as well, and so that will happen faster. And then temperature. If you increase the temperature, the particles move faster, so the reaction is faster, because the things that are happening are touching each other on a molecular level a lot faster. Does that make sense? So, three ways. Now, there's also, you can also increase a reaction using something called a catalyst. Wait, oh look, okay. Catalyst. A catalyst is a substance that increases the rate of a chemical reaction but is not consumed by the reaction. So here I've got this picture to show you what I mean. Okay, so I've got this blue thing, and this blue thing over here, an enzyme, and that's a catalyst. And this is actually like the saliva in your mouth, and the saliva in your mouth is an enzyme that helps break down the food so that you can digest the food, but you don't digest your saliva too. I mean, it ends up going down there and whatever, but the enzyme isn't part of what's digested. What's happening is you're putting these two things together, and the enzyme is helping these two sit together long enough for the reaction to happen. So it's kind of like a little home for it. Let me make you comfortable and help you sit still while this happens, okay? And then once you get the reaction to happen and you get your new product, then it can go off and be its new product, and the enzyme doesn't change, it doesn't become a part of it, it's not a part of the chemical reaction, it just helped it along a little. Anyway, there you go. Those are all your chemical reactions. Good luck, and I'll see you soon.